look at those. Kylie, you want to start some?
I can understand and work with radicals.
Keep going.
I can classify real numbers as rational or irrational according to their I can say examples of rational and irrational.
So we started at the beginning of the year with rational and irrational. That was like in unit A1, A2, something like that right at the beginning. So we're going to be kind of still looking at those types of numbers and doing some classifying. So when we think about this, this is our index. This is telling us what root we are taking. So it's telling us that we are taking the cube root of this whole radicand, which is x minus 4. And this square root symbol is called the radical symbol. So just kind of your notation for what things are looking like as we start this, okay? So if we are looking at square roots, by definition, the square root of a number is when it is multiplied by itself to equal a given number. The square root of 16 is 4, because 4 squared is 16. So using words, if we are looking at that, it says the square root of 16 is 4 means I multiply 4 by itself to get 16. So, keeping the ones that are fractions, fractions, please do these next 4. Most of those you should probably recognize, right? The paper I saw had 8. The next one I saw most of you on your paper have 5. The next one we want to keep it as a fraction. So the square root of 1 is 1 and the square root of 36 is, so 1/6. And the square root of 81 is 9 over the square root of 121 is 11, so 9/11. So when you are working with the square roots of fractions, keep them as fractions. I don't want you to put them in your calculator and get a decimal. So we're going to keep them simplified in that way. Okay? Top of the next page in your notes. It says radicals without index are always square roots, meaning it's a 2. If there is an index of 3, we are finding cube roots. If the index is 4 or higher, we are finding the 4th root or 5th root. A cube root means that a number to the 3rd power equals that radicand. Example. The cube root of 27 is 3 because 3 to the 3rd equals 27. If you were going to continue reading with that, Jacob, would you read where it says the 4th root?
The 4th root means what number to the 4th power equals the radicand. Example, square root of
4th root of
16 equals 2 because 2 to the 4th power equals 16.
So now we're asked to simplify these next numbers. So, one number times itself 3 times, it's going to give us 64. Should be. You don't have any idea? Remember? Should be 4. Key thing when you're looking here, at the cube root of 125, it ends in 5. So it's possibly going to be 5. 5 times 5 is 25. 25 times 5 is 125. One number times itself 4 times equals 81. Well, first you might even start thinking of the square root, right? And the square root would be 9 times 9. If you're thinking that equals 81 or the factors, and it is 3. So you have 4 3s that multiply to give us 81. If it's a 5th root, it probably has to be a pretty small number, right? So if we're looking at 32, probably a multiple of 2, and does it make sense that it probably is 2, right? 2 times 2 is 4, times 8 is, times another 2 is 8, another 2 is 16, another 2 32, right? This one is telling us the 4th root of 10,000. Key thing, looking at those zeros, right? So our answer should be simply 10. 10 to the 4th power, right? That just means if we are looking at 10 to the 4th, that does equal just 10,000, right? So when we're thinking about those numbers, looking at that. So beginning of the year, in our Math 8, this is where we start the unit. You do have to memorize these squares and cubes. So when we start taking the state test, NDSA, there's a lot of stuff with squares and cubes and the calculators don't come up on them. So a perfect radicand is a perfect square, a perfect cube. is equal to a whole number. All other radicands are non-perfect radicals. Equal, they're going to equal decimals, but do not ever repeat with a pattern. So when we are looking at these, it says you will need to have these 30 facts memorized. Knowing these by memory is going to make this whole unit much easier. I will have students say to me, Mrs. Thompson, what if I don't memorize it? It says it's going to make this so much easier if you have these down. And most of them you probably already have down through 12, right? You probably know 1 times 1 and 2 times 2 and 3 times 3 and 4. You pretty much know this whole group probably pretty well up to here. So really, what do you have to memorize? You have to maybe memorize from maybe 13, but if you have 13 is 169 and this is 196, you're just switching around those last two. And 15 to 25, and then so maybe the ones you really have to memorize are here, because 20 squared isn't hard to memorize, right, or to know. It's 20 times 20, or 2 squared is 4, and then add 2 zeros, because you had a 20 here. 10 to the cube, that shouldn't be hard to memorize. But I would say that some of these in this range, this 216 to the 720, 729, those are going to be ones that might be harder. So, I will attach on the daily planner some Quizlets that are just simply much the squares and cubes, so that if you want to practice those or work on those. But you do want to think of memorizing those. It says you probably have many of these down. Take a minute to look over the list. Circle the ones that you don't already know. So if you're going through it, you can't go, oh, 16 times 16. Circle that one. Those are the ones you need to work on. Do you need to work on any of the other ones? No. You have them down. It says no, you need to know this both ways. In other words, you should know that 4 squared is 16 and the square root of 16 is 4. Okay? So, in reading, Brecken, would you please read?
To estimate the value of the radical, you must find the 2 perfect radicals closest to it and then determine the approximate value.
So if we are going to continue with this, it says, example, the square root of 34 is smaller than our square root of 36, which is 6. It's larger than square root of 25, which equals 5. It is much closer to 36, therefore we're going to say the square root of 34 is approximately equal to 6. If we're looking at the cube root of 30, cube root of 30 is definitely between the cube root of 64, which equals 4, and the cube root of 27, which equals 3. Much closer, so we're going to be asked for the approximate and not as a decimal. So, looking at that page before, if you need to, we are looking at the cube root of 9, which means the cube root of 9 is between what? The cube root of 1 and the cube root of, or cube root of 8, excuse me, and the cube root of 27, right? We're looking at that one. Much closer to 8, so we're going to say that this is approximately 2. Really? You think 9 is between?
No, I said what if it's like the number.
Oh, exactly in the middle?
Like what if
It's usually going to be closer to one or the other. So you're going to go approximately, and we're just asking you to tell the whole number, not the decimal approximation. Okay? So again, I'm going to look at the square root of 60. I'm going to say the square root of 60 is between what 2 perfect squares? So please write down the 2 perfect squares that it is between. Okay? So square root of 60, if we are looking, is going to be between 49 and 64. Much closer to 64, so we're going to say approximately 8. So this one's saying the 4th root of 20. If we are thinking of 2 to the 4th power, 2 to the 4th power is what number? 16. And if we think of 3 to the 4th power, that is 81. And if you're not quick with that, if you're thinking, okay, that's going to be 3 squared times 3 squared, 9 times 9, 81. This one, again, you could be thinking that it's 4 times 4. That's how you get to 16. So this one, would we say it is much closer to the square root fourth root of 2 or the fourth root of 3? 2 for our answer, right? So thinking about those perfect squares or cubes that it is in between, and if you're not sure, generally they're pretty small numbers if it's a fourth root or a fifth root. So between like 1 and 2 or 2 and 3, maybe 3 and 4. So these are the sets of numbers we had towards the beginning of the year when we were looking at our sets of numbers. We have natural numbers, which are kind of like our counting numbers. They start at 1, 2, 3, 4, continue. Notice there's no fractions or decimals. Whole numbers include 0, so it's the naturals plus 0. Integers are the whole numbers and their opposites, meaning anytime we are writing that, we are looking at 0, 1, 2. We have -1, -2. Again, no fractions or decimals. A rational number is simply any number that can be written as a quotient, just means as a fraction, a over b, where a and b are integers and b can never be 0. The reason b can't be 0 is what happens if you divide by 0? Undefined, right? So this includes terminating and repeating. I'll often have people tell me that terminating and repeating are irrational numbers. They are not. Every repeating decimal can be written as a fraction. 0.3 repeating can be written as a fraction. It's 1/3, right? And if the decimal ends like 0.25, you can write it as a fraction. It's 1/4, right? So as you're looking at those. Irrational numbers, and so I give you a list of examples. Irrational is any number that cannot be written as a quotient of 2 integers. Pretty means you cannot write it as a fraction. So if you look at the numbers, it says all decimals that neither terminate nor repeat. So if you look at this one, 0.10, 0.100, this is a pattern, but it doesn't repeat, right? So this one cannot be written as a fraction. Pi. Someone says, oh yeah, but it's 22/7. But when we take a look at this, if we're actually looking at pi, that's an approximation, same with 3.14. It never repeats and never ends. Now look at the poster that I have up in the front. I have quite a few digits of pi, but I cut off the last part of that poster. So it doesn't end, doesn't repeat. Real numbers are going to include all the rational and irrational. So when we are talking about our sets of numbers, real numbers, the most broad is real numbers. Then we are going to break it down into rational and irrational. From rational and irrational, once it's irrational, you have no other choice. But if it is rational, -3 actually is an integer and a rational number and a real number. If I'm looking at 4/2 or square root of 25, 7, they are natural numbers, they are whole numbers, integers, rational, and real. So when you are thinking of this hierarchy, if it is natural, it's in all of these. Whereas if it's just a fraction or a decimal, then it's going to be just rational and real. We also talked about, besides real, there's also imaginary numbers. You won't deal with those till algebra 2. That's when you take a negative square root. So on the next page, you are asked to classify. So if you are asked to classify, it says in each number an element set. Put a check mark if it is, put an X if it is not. So, and 3 can be written as 3/1. So if we are looking at 3/10, definitely rational. -0.45, rational or irrational. Again, it can easily be written as a fraction, right? 45/100, if we were doing that with a negative. So, we know if it is rational, it cannot be irrational. So it can't be both of those. Now the question is it an integer or whole number for either of those two? That should be, these should be X's also, right? It cannot be, whole numbers and integers are never going to be fractions or decimals when you are thinking about those. So now we have square root 12. Square root 12. Can we find the square root of that? Is it one of our perfect squares? No. If it is not a perfect square, if you put it in your calculator, it will show a decimal that ends, but it really doesn't end. It is irrational. Square root 12. If you would have a device that you could put it on and show it never repeats and never ends as a decimal. So all the rest of those should be X's. So if it is irrational, cannot be rational, it can't be any of the categories with rational. If it is rational, it might be one of these, but it might not. For example, if I was looking down here, you are now asked to place, write each number -7, -5.43, 0, 3/7, pi, square root 7. In the boxes below, the number 5 has been placed for you. So we know 5 is rational, or is a natural number, and it also fits being in all these other categories. So right now, what I would like for you to do, we have 0 in that one. If we are looking at one of your irrationals, one of our irrationals, Ben, would be what?
Pi.
So we could have pi for one of our irrationals if we are looking at it, right? So we definitely have pi for one of them. If we are looking at an integer, what am I looking at? We could have definitely have -7. So our integers have our negative sign. So this whole number is an integer, as is 5, but this is the only one that's an integer, not a whole number or natural. If we are looking at our rationals, Cassandra, you want to tell me what you had for both those?
3/7 and -5.
Yes, so 3/7 and a -5.43. So it can be positive or negative, and then our last one, square root 7 should be 50. So, as I was mentioning, those of you that finished, trying to write down without using your calculator or looking at your notes, trying to write down as many of them as you can. And the ones that you can't do, that's what you need to memorize. So when you're thinking about this list, most of you, the 1 to 10, not a problem, right? 1, 4, 9, 16, 25, 36, 49. So like I said, if I'm giving you a quiz on this and ask you to memorize it, I'm not giving you a lot of time to do that. Again, here's where people start, 121, 144. And if you can get to 169, the nice thing is, the next one is 196. We know 15 squared has to end in a 5, and it is 225. And they have to keep getting larger. So the other thing I'll have students, I'll have them change these two around, or these, it doesn't make sense, right? You're getting bigger. The other thing is if you always kind of think of, I had some people say, oh, you know what, I noticed that there's a pattern. There is a pattern every time that I'm adding on. So 121 to get to 144, what do you have to add? 23. 144 to 169, you're adding 25. 169 to 196, you're adding 27. So sometimes patterns are a beautiful thing, right? So what if you didn't memorize? Does that pattern keep going all the way down that table? Yeah. So if you can get to memorizing them and you kind of go, oh yeah, I know 196. Now, the thing is that most of the ones that we use for being memorized when we simplify our radicals are going to be from 1 to 100, those perfect squares. So know those. And I'll say, you want to factor this number into a perfect square and another number that multiplies to give us. So we're mostly using that first column, okay? And again, in the cubes, again, a lot of you will get the first 5 pretty easily, and then it's 6 to 9 that give problems for people. So just know that that's kind of what you'll need to work on. All right, so the assignment is not due until Tuesday of next week, right?